what I'm doing is, technically it was like this was my clock and this was my receiver. So in between this, or in this path, what I did was I broke the interconnect so that my delay reduces. And when I broke the interconnect, I started connecting inverters or buffers to restore the value of the signal. And I started grouping them. So group of 4 was driven by one, a group of another 4 was driven by another inverter, 4 another, group of 4 another. And this 4 in turn was being driven by my another inverter which had clock as its input. So basically what we are trying to understand is an inverter driving some blocks, which in turn is driving some other blocks. The same thing which we understood for H tree, where you drive a group and group drives another groups, exactly the same. Now we have reduced the length of the interconnects here, and here if the values of the capacitance, which was a problem in H tree, are different, what we can do is we can size these inverters in such a way such that still all the delay or all the points can still receive the clock at the same time, and that sizing is nothing but sizing of inverters through a concept called as logical effort. So we can try to do that. This is just nothing but an internal diagram of this interconnect where I have replaced all the interconnects with the pi model of RC delay, and I have explained the same thing. Now you might also understand that this is a symmetric circuit. Sometimes the circuit might not be symmetric, and in that cases, when you try to use logical effort, it would be quite better if you use a single buffer chain. What does that mean? Suppose these are all different blocks or receiver points which needs to be driven by clock, and the entire circuit is not symmetric. So what I do is I connect a chain of inverter. If you see from a smaller size to a larger size, that means I have sized my inverter with different values of W and L, such that my point X receives the clock in a way that it can drive all these points with a delay which is nearly equal, and that itself is a challenge. So these are some of the challenges which you face when you try to do clock distribution or clock routing. And that's the reason these days we also have heard about something called as asynchronous system. Asynchronous systems means something which does not depend on clock. We have already seen this where you have this control signal, correct, which is coming out, and at the same time this control signal might be given to your logic block, which will have inputs and outputs. So your control signal will ask the circuit, are you ready, by sending a request. Once the circuit is ready and gives its output, it will give an acknowledgement. This is nothing but the concept of handshaking, which we have already studied, in which you don't have to be dependent on clock, because right from generating the clock to stabilizing the clock to distributing the clock at different receiver points, it's quite a challenging task. In this clip, we saw that the clock can be distributed to different receiver points by grouping them. We also saw the concept of partitioning. We saw that partitioning and grouping helps us to make the groups, but then still to drive that groups is itself a challenge. So we saw the concept of edge trees, in which we saw that the length of the interconnect, if being same, all the receiver points might receive the clock at the same time. And we also needed to ensure that the load capacitance value is same. But that itself is quite a demanding or a daunting task, and hence we moved ahead and saw the concept of driver trees and single buffer chain, and how do we need to size our inverters to the concept of logical effort by breaking the interconnect lines or by breaking the interconnects and ensuring that the delay value or ensuring that the clock tries to reach all the points at the same time. And with all these challenges, we also saw that if we want to overcome this, or if we want to move towards an asynchronous system, we have the concept of handshaking. Hope you have followed this. Stay tuned for further clips, and thank you very much.